It's the experiment that nearly broke Einstein's brain. Welcome to the dojo, everybody. It's called the Double Slit Experiment, and I'm here to try to explain it to you.
No, there is no try.
But the problem is, it's not really that easy to explain. But if I do it right, it might just change your life. Take a deep breath, focus. Let's start with the basics. Isaac Newton back in the 1600s argued that light was made of particles, while another famous scientist, Huygens, argued that light was a wave. It wasn't until the 1800s when a scientist named Thomas Young figured out a way to finally put this to the test. He took light and projected it onto a wall with two slits onto another wall behind it. You'd expect to see two bars of light on the other side, right? Well, that's not what happened. Instead, what he saw was multiple bars of light of varying intensity that scientists know is a clear signature of what is called a diffraction pattern, and this is caused by waves. You can see this for yourself by agitating water with a single source. It sends out waves just as you'd expect. But if you add another source, the waves interfere with each other and either cancel each other out or amplify each other depending on where and how they interfered with each other. Okay, so light is a wave then, right? Well, kinda. Here's where it starts to get weird. Buckle up. Scientists realized that firing thousands of particles or photons through the slits could cause them to simply collide with each other and make it look like a wave, but not actually be a wave. So they decided to shoot one photon through the wall at a time. Yet once again, the diffraction pattern, which suggested that somehow this single photon went through both slits and interfered with itself. Here's where it gets really weird. They decided the best way to figure out what was going on would be to put a detector at the slits to see which slit the photon actually went through. Are you ready for this? Are you sitting down? When they turned the detector on, the image on the far wall went from a wave pattern to two slits instantly. When they turned the detector off, it instantly went back to a wave pattern. And this experiment has been done thousands of times in thousands of laboratories, so this isn't woo-woo science, it's established fact. So somehow light behaves like a wave until it's observed, and then instantly becomes a particle. To this day, we still have no idea why this happens or what causes it. It eerily suggests that particles somehow know if they're being observed or not, and they alter their existence based on that knowledge. The double slit experiment has been repeated with all sorts of particles from electrons to atoms, and it always yields the same results. But a wise man once said that the ultimate response to a science experiment isn't eureka, it's Now I can stop there, that's plenty of weirdness, but let's take it up a notch and move into the theoretical realm. In modern times, where we see this kind of behavior is in computer simulations. You see, in video games like Halo, the entire game is far too big to be fully rendered inside your computer. For efficiency, the game only renders the portion of the game that it needs to based off of what your character needs to see to play the game. So could we be living in a computer simulation? Yeah, we could. But in another strange twist, spiritual mystics for thousands of years have been saying the same thing, that human life is not the base reality of existence, that there's something way beyond this physical universe that meets our eyes. If right now you're totally confused, don't worry, that's pretty normal. But if I did my job and your brain is about to explode, you're in really good company. Einstein went to his deathbed with no idea what causes this. Now, if you find the simulation hypothesis an intriguing idea, and you should because it's pretty cool, check out these two videos about the hypothesis. One from the material world point of view, and the other from the ethereal world point of view. Go ahead, click on it. Well, you won't actually be clicking on it. A simulated mouse will put a simulated cursor over it, and then you can simulate a click on it, and even the noise of the click is simulated, so click on it, because it'll be kind of cool. Go ahead. I got plenty of time.